Hey everyone, and welcome back. Today, we're diving into something that feels like it's straight out of science fiction, but it's very real. A new AI-driven way to manage cloud resources. So forget everything you know about setting static limits or, manually scrambling when you get a sudden traffic spike. We're talking about an approach that can literally predict the future to make your cloud services faster, cheaper, and just way, way smarter.
But before we get into the tech, let's start with a question that probably hits pretty close to home for anyone who's ever managed a cloud budget. Are you overpaying for your cloud? Chances are the answer is yes. Wasting money on resources you don't need is one of the biggest headaches out there. And today, we're going to unpack a really powerful new way to solve that exact problem.
Okay, so here's our game plan. We'll kick things off by looking at the old way of scaling, the stuff that causes all the problems. Then, we'll introduce this smarter, AI-powered approach and actually peek inside its brain to see how it ticks. After that, we'll get to the really exciting part, the performance results. And finally, we'll zoom out and talk about what this all means for the future of the cloud.
All right, so to really appreciate just how big a deal this new technology is, we first have to understand the world it's replacing. Let's break down the traditional, and let's be honest, often super frustrating ways people manage cloud resources today.
So you've basically got two main villains in this story: static provisioning and manual scaling. On one hand, with static provisioning, you just guess how much capacity you need and set it. This almost always leads to paying for a ton of server power you're not even using. But on the other hand, manual scaling is just too slow. It relies on a human to notice a problem and react. But by the time they do, your app is already slowing down or crashing. So either way, you're either wasting money or you're risking a terrible user experience. So, what's the alternative? Well, it's a complete shift in thinking. It's about moving from being reactive to being predictive. And this is where our hero, an AI-powered framework, finally enters the picture. The whole point is that it doesn't just respond to problems after they happen, it sees them coming and acts ahead of time.
So let's take a quick look at how this thing is built. Everything starts over here on the left with the data collection layer, which is just constantly drinking in real-time metrics. That data then gets fed into the AI model layer. That's the brain of the whole operation. You can see it's got two jobs, prediction and optimization. From there, the decision layer carries out the plan. But the really clever part, I think, is this feedback layer over on the right. It takes all the performance data and sends it right back to the beginning, creating this loop of continuous learning. It's basically a self-improving brain for your cloud.
And look, the goals of this system directly attack all those problems we just talked about. This isn't just about saving a few bucks. It's about building a system that can scale to handle any load, that optimizes every single resource so nothing is wasted, that cuts down latency so your users get a better experience, and that can adapt on the fly so you are never, ever caught off guard. All right. Now for the really fun part, let's pop the hood and see exactly how this AI thinks. How does it actually make these incredibly smart, predictive decisions? The whole process really breaks down into 5 pretty logical steps. First, it gathers up and cleans all the incoming data. Second, it uses that data to forecast what's going to happen next. Third, based on that forecast, it figures out the absolute best way to arrange the resources. Fourth, it makes it happen and watches to see what the results are. And fifth, and this is the real magic, it learns from that outcome and updates itself to be even smarter the next time around. You know the saying, garbage in, garbage out, right? Well, this whole thing starts with getting really good intelligence. Just look at all the different data sources it's pulling from. Resource logs, workload patterns, basic cloud metrics, even records of past failures. The system hoovers all of this up, processes it, and gets it ready for the AI. It's this incredibly rich, diverse data set that lets the AI build a complete picture of what's happening now and what's about to happen.
Now, the way the AI learns is what's really key here. It uses a technique called reinforcement learning. The easiest way to think about it is like training a puppy. When the AI makes a good decision, like it scales resources perfectly to meet a demand spike without wasting any money, it gets a reward, like a little digital treat. If it makes a bad call, it gets a penalty. And over millions and millions of these little trial and error cycles, it learns the absolute best strategy to get the most rewards.
So the AI brain actually has 2 parts working together as a team. First, you have a supervised learning model that acts like a fortune teller. It looks at all the past data to predict what future demand is going to look like. Then, that prediction gets handed off to the reinforcement learning model, which acts like the master strategist. It takes that prediction and decides the most efficient action to take. It's this 1-2 punch of prediction and then decision that makes it so powerful. Okay, the theory is great, but what about the results? Does it actually work?
Well, let's look at how this thing performed in a real-world simulation. And to be honest, the numbers are pretty staggering.
First up, the one everybody cares about, the bottom line. This AI-driven framework cut cloud costs by up to 40% compared to the old manual methods. I mean, just stop and think about that. That is a massive amount of savings that could completely change the economics for so many companies out there. Next, let's talk efficiency. The system boosted resource utilization by up to 30%. In simple terms, that just means less waste. You're getting way more performance and value out of the exact same hardware simply because it's being managed more intelligently.
And finally, maybe the most important one for your customers, the user experience. The AI model was able to cut latency by up to 20% during peak traffic. That means your apps and websites stay fast and snappy right when it matters most, which keeps your users happy and engaged.
And hey, don't just take my word for it. The researchers who actually developed this system, Beeman Barua and M. Shamim Kaiser, they concluded that their framework is, and I'm quoting here, a strong and scalable solution to managing cloud resources in dynamic and performance-critical environments. I mean, that's about as strong an endorsement as you can get.
So let's just zoom out for a second and think about the bigger picture here. We've seen how it works, we've seen the incredible results, but what does a technology like this really mean for the future of cloud computing itself?
If you're going to take away just a few things from our conversation today, it should be these. First, this is a huge shift from being reactive to being predictive. Second, it delivers massive wins for both your budget and your performance at the same time. And third, because of that feedback loop, it's a system that is always learning, always getting smarter, and always getting more efficient.
And all of this leaves us with one final, pretty provocative thought. As our digital world gets more and more complex, managing it all by hand is quickly becoming impossible. So the question isn't really if we're going to need intelligent automation like this, it's when does it become standard? Will every cloud deployment, from the smallest startup to the biggest enterprise, soon need its very own AI brain just to keep up? It's definitely something to think about.